Okay. Let's do a recap on what all we did. We said that why functional programming. Functional programming is nothing but immutability. Uh, Immutability is very good for parallel programming. We saw that uh, the discrepancies happen because there is parallel programming and mutable state. Whenever there is a mutable state, you need to put lot of locks and all to maintain the concurrency in your programming. So that's a tougher thing, and if you maintain immutability, then it's become much easier. And immutability means here functional programming, and Scala uh, is a good at functional programming, and also it is a pure object oriented programming. So we need to, that's what is all about functional programming, and Scala is functional programming language. Scala is also type inferred, means it will infer the type for you. You need not specify the type. Even though you want to specify the type, you can give it at the last. Whenever you are declaring an identifier or you are declaring a function, defining a function, the return type or the data types will always come at the last. Then we saw it is statically typed language. That's because the data type is always inferred, and it knows what data type is, what identifiers or functions is all about, and based on that it can resolve most of the errors at the compile time itself. Syntactic errors or some runtime errors in some other language could be resolved at the compile time itself. That's a big gain on programming languages. Then we saw normal variables, how everything like basic data types. Then we saw val, then we saw var. Val means constant, and Scala, as I said, by default supports immutability. It means all the Scala collections are by default immutable. If at all you want mutable, you have to explicitly ask for it. Even val is immutable. That is, whenever you declare any private variable in a class, that is by default immutable. If you don't specify val or var for members of a class, those are all by default immutable. That's what makes Scala language as immutable. Then we saw normal basic data types like int, double, strings. Then we saw if conditions, for comprehensions. We also said that the for comprehensions are much more powerful than for loops in any other languages, because underneath it is implemented using higher order functions. Just remember as of now, because we will cover more of higher order functions later. But just remember that for comprehensions are underneath implemented with higher order functions. And we also saw how pattern matching is done in Scala. Even it is much more powerful than the switch cases in other languages. You can pattern match on literals, we can pattern match on variable binding, we can pattern match on underscores. Those are underscores, and variable bindings are the wildcard pattern matching. So you can also have, once you have variable binding, we can have pattern guards, which are nothing but if conditions on the pattern matching. So these are things we saw in our previous sessions. We also saw if else conditions. If at all there is only if condition, we saw that the return value is always any. I hope we covered all those things, right? We were supposed to start from functions, right? Yeah, okay. Let's go with simple functions. And one more thing in functions is, functions are called first class citizen Scala. What that means is all functions in Scala are implemented as objects, are implemented using classes, and all functions are treated as a result, all functions are objects. So whenever all functions are objects can be assigned to any other objects So functions could be assigned to any other variables, identifiers. Functions could be passed as a parameter to another function. Function could be returned from a function. Functions body, that is called function literal, could be passed as a passed as a parameter to a functions. So all these could be possible. That's because functions are implemented as classes, which results in function objects. So let's see how a simple function looks like. This is our simple function. Def is the keyword, then we have the function name, then we have equal to sign, then here is the body of the function. You can have a single line body or usually multi-line body. So we can get rid of, if it is a single expression, we can get rid of the open bracket and close bracket. This is a simple definition of a function. And the function name and the body is differentiated by the equal to sign. The equal to sign comes because we say that in Scala everything is an expression. So you have to always return something from an expression, and we are assigning those return value to something else. So this is how a function syntax looks like. We have a def keyword, identifier, any name. The data type has to be specified. Otherwise, it means it's not mandatory to specify, because this is the return data type of the function.
Hello?
Yeah. Any questions? Okay. Yeah, this is the return type of the function, which is optional, because the return type is always inferred from the function, inferred from the body of the function. Whatever is the last statement in the body of the function, whatever is the last expression in the body of the function, after evaluating that expression, whatever is the data type, that is the data type, return data type of the function. So these are parameters related functions. You can pass the parameter. If we are not specifying any parameter, you need not specify open bracket and close bracket. So those are all got rid of. There is also no return statement in the body of the function. Let's take the simple example. We have a def multiplier. We are passing int x int, y int, and the return type is int, and the body is x star y expression. So we are seeing that there is no return keyword here in the body of the function, because it's not required, it is redundant, but it could be specified. It's optional. It's better not to specify it. And also whatever is the last expression in the block, that will be evaluated and returned, and based on that return data type, Scala compiler will automatically infer it. Here I have given it, but it is not required at all. But these two are required always. Otherwise we cannot differentiate between function overloading. This is one more simple sample example. So these examples we will be using later in our higher order function. That's the reason I have put it here. This is a function that takes a string and returns a string. And if the string is null, I am returning null. Otherwise, we are trimming it and returning whatever is the value, whatever we pass to the string, to this function. Yeah, these are all like just to remember that a procedure is a function that doesn't have a return value. Not much of a significance, probably in interviews that maybe they may be asked. So, but yeah, the procedure is a function that doesn't have a return value. Any function that ends with a statement, as I said, a statement is a an expression that does not return anything. So if at all a function has the last expression as a statement, then that function will be a procedure. Okay, so these are all things not required, means just to remember that difference between functions and procedures. Yeah, function with empty parentheses, these are all optional. That's what we saw in the beginning. If you see this is the function that doesn't have any parentheses. It is always optional. You may specify or may not specify, it's one and the same. Function invocation with expression blocks. So if you see here, we have a function which takes one parameter. So instead of directly passing a parameter to this function while calling this function this way, this is one way of calling the function. We pass the parameter, exact value or some value, or we pass an expression. After whatever this expression is evaluated, the last value will be passed as a parameter to this function. This is also possible. So whenever we specify an expression, we need to have open flower bracket and close flower bracket. Otherwise, this is the normal way of calling a function. But we can also pass expression block. It will be evaluated first, and whatever is the last expression, evaluated value of the last expression, that will be passed as a parameter to the function. So these syntaxes you will find in the most of the Scala programs. I think we had covered recursive programs and all, right? Anyway, yeah, recursive functions are the normal recursive functions where stacks frames are built upon with every call to the function. And we saw that by adding tail recursion, we can get rid of that stack frames, and only a single stack frame will be available, will be reused again and again, provided the last expression in the function is a call to the same function. And the tail recursion annotation says that it tries to optimize the function. It tries to optimize the recursive function so that it uses only a single stack frame. More than one stack frame will not be used. A single stack frame will be reused again and again for the recursive call, provided the last statement in the function, a last expression in the function, should be called to the same function. I think we did cover all these things. Then we have nested functions, which is nothing but function inside a function. Mostly we'll see like JavaScripts being written in this fashion. So here we are defining a function inside this function. After the definition of that function, we are calling that function. So this is like a private function inside the first top level function. So the nested function will not be available to any, it will not be visible to any other function outside the higher top level function. So these nested functions are usually used for code reusability and private kind of a function, to restrict the scope of the function so that it is not visible outside the top level function, and mainly because you can reuse the function. So here what we are doing is, this is a simple max function definition, right? Max of x comma y, it will give us whether x is greater than y, then x, or else y. So it just gives us the maximum of 2 values. Now suppose we want maximum of 3 values. Instead of rewriting the function with if else conditions, we can reuse the already written function. So that's what makes nested function a bit of, it is mainly used for reusability. I think next we had calling functions with named parameters. These are all similar to any other programming languages. We specify the name of the parameter and pass the value. We specify the name of the parameter because in the definition, if you see, we have 2 parameters, one is prefix, one is name. So we are calling that function with the by specifying name of the parameter and passing the value. So it makes like you need not give the parameters in order. It could be in the any order. That's what makes named parameter very useful. This is next we have parameters with default values. This is again similar to any other functions in other languages. We have default values. If at all we don't specify any value for that parameter, the default value will be picked and that function will be called. If you see, here is a function greet with parameter prefix of the type string, and the default value is null string and name is string. So suppose we are calling here the greet function and we are not passing the first parameter. So by default it will take null string as the prefix. So these are like any other function in different programming languages. And next we have variable argument parameters. Again, variable argument parameters is to pass variable number of arguments to a function. So we need to just add a star to the data type. So it will take variable number of arguments. If you see, this is the way it is called. You can call it with any number of parameters. Here we are calling with 3 parameters, but you could also call it with any number of parameters. Here we are calling it with no parameters. So it's just like how we pass arguments to our main function. So that's what functional, these are the different varieties of functions, how and all you can define a function. Then we have currying. This is, you can till now you might have seen a single parameter group, a single parameter list. We can also specify multiple parameter list. So these we will see later what is the use of this. It is again like you may specify while calling the function, you can skip one of the parameter list and we can give it later. You can pass that missed parameters later somewhere else. So we'll see, just remember that this is also a syntax of Scala. We will see more examples of these kinds, why it is used, what is the use of multiple parameters. But just to remember, this is also a valid syntax in Scala, passing multiple parameter list. Again, it will be used for reusability of the code. Just remember that it will be used for reusability of the code. Next we have type parameters with respect to functions. Type parameters with respect to functions is nothing but which will be used for generic types. Suppose you have a function and you want to pass any data type. It should handle integer data type or double data type or any other data type, just like generics in Java. So the way we specify is data type as A. It means any data type, or this A is just it could be any character, capital letter. It's a convention, just a convention of specifying a character, bigger character, capital letter character. You could also say that it could be B, and here it will be P. It means this function you can pass any data type, and capital letters are the way of specifying this type parameters for functions. It means if you see here, now this function could be called with any data type. First we are calling with string data type, next we are calling with double data type. Also this data type specifying while calling is again redundant. We can get rid of these things. Scala compiler will come to know, will infer it for you. So you can directly specify identity as call identity with string and call identity with double. So this syntax means it's a generic function. Mostly when you write libraries or expose your own APIs to others, you want it to be generic. That's where you will be writing a generic API that can take input any data type as the input. Here in our case we are calling it with string and double. We can also call it by integer or any character or an object, anything. Yeah, methods and operators are here. We have an object and we have methods for that. Here in Scala there is nothing like operator. Everything is a method. We don't have plus operators, we don't have minus operator, or we don't have multiplication, division operators. All those symbols are functions on the object, integer object or double object. So this is nothing but an object, and we are calling the method of that object, just as normal in any Java programming. We have an object and we call method of that object. Here a string has a method with ends with method. String is an object and it has an ends with method. Similarly we have double dot round. Round is the method of this object. Floor again the method of this object. Compare again method of this object. If you see, this is, as I said, plus is not an operator in Scala, it is a function, and this is how you call a function. We have this object, then using the dot reference we call the plus method and pass a argument to that function. You can either use the dot parameter or just give a space and call this way. This is also a valid syntax. We have object, space, method of that object, and then pass the argument to that object. So this is mainly used when we do arithmetic kind of operations on the strings, doubles or integers. This is a valid syntax because we have object, space, method on that object, and this is the parameter that is being passed to that method. So but it is recommended not to write in this fashion, so it is confusing a bit. It is always recommended to use arithmetic kind of operations, to use such kind of a syntax like a plus b, c plus d, a minus b, a divided by d. So all those are specified in this format. So always specify the arithmetic operations in this format, and other than that try to specify using the dot operator method. Dot method, object dot and method, and then pass the argument to those things. Yeah, these are simple function definition what all functions are. So now comes our first class functions. In Scala functions are called first class functions. What it means is the term indicates that functions can be created in literal form without even having been assigned an identifier. You need not specify a name for a function. We can directly write a body for the function. That's what it means, literal form. Literal form means you need not give a name to a function. You can directly write a body to a function. Can be stored in a container such as value, variable, or any other data structure, because functions are implemented as classes and functions are objects. That's the reason we can do all these things. Assign to some variable or value or any other data structures, and to be used as a parameter to another function. You can pass a function to a function or return a function from a function. That's the reason it is called first class functions. And the reason behind it is because Scala is a pure object oriented language. Everything is an object there. Even the functions are objects. So let's see, here it's a bit more important, because most of the Spark or Scala languages are based on these things, are written as higher order functions or function variables. We are having a simple function here, double definition. The function name is double. It takes an integer and it will result the double of that integer. Double in the sense it will multiply by 2 and give the result. So if we see here, we have double, we are passing 5 and we are returning 10. Means it is evaluated to 10 and assigned to something else. Now this is very important here. If we see, we saw that val x then int equal to 10. Now what we have here is val my double, then we have colon, then we have this, then we have this double. This is what we are having here. That's what this shows. Okay, let's put the open bracket and close bracket also, but it's not mandatory for single parameter. What does this mean here? Now if we compare the first expression with the second expression, first statement with the second statement, x is a identifier and then we have colon, then we have the data type of the identifier, and then we are assigning a value here. Similarly, my double is an identifier. After colon it should be the data type. This is the data type of the identifier. What does this data type mean? This is the data type of function variable. It means that my double is a function variable. It takes int as an input parameter, and its return value is again int, and then we are assigning to that identifier or function variable the actual function. So it is just like if you remember C programming, we had pointer to functions. Just visualize in the same way that my double is kind of a pointer to this function, and the data type of this function variable is, it takes integer and returns integer. This is the data type of a function variable. It takes integer and the return data type is a int. So let's try to execute this. This is our simple function def double, which takes an integer and multiplies it by 2 and returns the value. Now we will define my double is a function variable, and its data type is it takes integer and its return value is this, and we are assigning double function here. Yeah, it says that it is a function. This is just like a pointer to function now. Now we can use my double and pass actually the value. So actually this function will be called. That's what makes function as a first class function now. First class citizen in Scala. Any doubts here? Shall I continue? Yeah. We can also specify a placeholder like this. So this is one way of defining a function variable. We give the identifier name and we specify the data type in this way. Whenever you specify the data type in this way, it says it is a function variable. We can also specify double equal to double of. If you specify underscore, okay, and we are not passing the parameter, if you see, actually we are calling this function here. We are not specifying the data type, okay, and we are calling the function here, but we are not passing the parameter. We are just placing an underscore here. When we do this, it will create a function variable. By placing an underscore means we are not passing the parameter as of now. We will pass it later somewhere, some other time, somewhere else in the code. We will pass somewhere else in the code. What it will return? A function variable. This will also create a function variable. Again, this is again used for reusability. We will see more examples on what's the use case of specifying an underscore and not passing a variable at that parameter at that time and waiting for some other time to pass the argument. So now we can I didn't get the question.
But it is showing int na INT.
It's showing int. Where? This one?
Yes, Pawan.
Is this? Are you asking about this?
Yes, Pawan.
Yeah. This it says that my double is a function variable of this data type. Yeah, that's because whenever you specify underscore and don't pass the, here double is a function. If you see here, double is a function that takes a parameter, right? But we are not passing the parameter here. Instead we are placing an underscore. It means that we can pass the parameter after some time or in any other place. This syntax will again return a function variable. This is one way of you yourself defining a function variable by giving the data type as this. This is one more way of defining a function variable by not passing the actual argument. This we can pass, the argument will be passed later, probably by using this function variable. If you see, it has returned the data type of this function variable as int, arrow and int. Means it takes integer as the input parameter and returns integer as the return value. This means, this data type means this is a function variable. So we can now call new my double to as 30. We can pass the argument now. So it will double it and give it the result. Again, this function will be called. Also, this is called partially applied function. Partially applied function means you don't pass some of the variables of the function, some of the parameters of the function. We hold back some of the parameters and we pass it later. Whenever we hold back some of the parameters and pass an underscore, a function variable gets created. And to that function variable, we can pass the parameters later. Is that clear? Yeah.
So this var new my double is equal to double space underscore.
Val, yeah.
So the function name is the val as a new my double.
Right.
Okay, the body of the function is a double, which will get replaced by the actual definition of the function.
Right.
Add space from underscore. So that underscore is a placeholder for the data type, the input data type, or exactly what exactly is it?
Yeah, that placeholder is a parameter of this double. This function double is there, right? It is supposed to take an integer as the parameter. But we are placing a placeholder here. We are not actually passing the function.
Okay.
We are not actually passing the parameter. Actually here this means we are calling the function.
Correct.
We are calling the function but we are not passing the parameter. Whenever we do this, this is partially applied function. So that function will not be called. Instead, it will return a function variable.
So the earlier example of the same as this, right?
Yeah, this one.
Yeah.
Yeah, here we are specifically saying that this is a function variable by specifying the data type.
So that is a type of that function?
Yeah, type of the function, and here the function is not being called here.
Okay.
We are just, yeah, we are just assigning the function to this function variable. But here it is being called, but since we are not passing the full parameter, it will be, if you see val this, let me call this with proper parameter. So here my double will be a normal integer variable with whatever after executing this double. So this function is called, it executed this, and that return value is assigned to new my double. Now new my double is a normal integer identifier. The same thing now we are calling, but without passing the parameter. Now what it happens is it will not get called. Instead, it will generate a function value. Function value. Yeah.
So how that function value return type has become as a function which takes int and returns int?
Yeah, means it is this function. We are holding back the parameter. We are trying to call, but we are not passing the full parameters.
Correct.
So it will not call itself. It will not call the double actually. It will hold back to be called later point of time. So it will return a function parameter, function value.
So that I understood that which is an angular bracket function 1, which is placeholder function of
Right,
double.
right,
But q my double, the return type for the q my double has become a function which
r-
takes int and returns int.
right.
How is it got that generated?
Because this double, because this double definition, you see, it takes integer as the input and return value is integer.
Okay.
So that got assigned to my double.
Okay. So the earlier example, the val my double colon int implies int is equal to double. We have it right here the same place.
Yeah,
So can we actually have my double which takes int and returns a double?
yeah. We can do that. So we can define a function like this. Define function x, we will divide by 2.
No. Don't redefine the double function.
Okay,
We just redefine my double.
okay,
My double.
okay,
Val my double.
okay.
Colon.
Data type is
We have a function which takes the int and but returns double.
double. So we need to assign that particular function.
And is equal to double. Does it work?
Yeah, it will.
So then basically what I understood is the return type of a my double should be the return type of the double, right?
It should be the return type of the double.
But here the return type of the double is int to int.
Yeah,
And,
yeah.
we have assigned the int to double. How did it work?
Right. Yeah, that's true. Because it has to be the return type of the double function. One second. Let's
Let's take the input as a double.
let's make it as this.
Okay.
Yeah, now I think it is. Probably it is like double could be assigned, int could be assigned to a double.
So it's downcasting.
Yeah, downcasting. That's how it worked. Otherwise, if you see, there is a mismatch error.
Okay, this one. Okay. Cool.
Yeah,
Makes sense.
yeah.
Maybe the upcasting or downcasting might work, but not a
Not the totally different data types. Yeah. So let's continue. Yeah, we will be using more of this function. Let's assume this to be a like we are not passing the argument as of now. We'll be passing the
unable to see your screen.
pardon.
I am unable to see your screen.
1 second. I think Sunil, you have to mute. Okay. Are you able to see now?
No problem.
You are not able to see because my screen is shared. What are you able to see? 1 second. I stopped the share screen. Yeah, now.
No problem.
This is Venkat or Anu?
Venkat.
Okay.
Venkat Rao.
You are not able. You are not able to see even now. How is it? How is it? Can you disconnect and connect again? Is it now or from long back you are not able to see? I can't hear you. Do one thing, just disconnect the call and connect back.
Okay, how could I connect?
1 second, I think it's the,
Yeah,
just disconnect, and on your window, chat window, I have pasted the link. Just click on that link.
hello?
Hello?
Everyone.
Yeah, now able to see. Just
Yeah,
mute.
I am able to see. Yeah, I am able to see now.
Pardon?
I am able to see now.
Okay, just mute yourself. Yeah. Uh, things were clear, right? We'll go ahead with next. What we have next here. Yeah, next we have the higher order functions. A higher order function is nothing but passing a function as a parameter to the function. A higher order function. Hello?
Yeah, Pramod, can you just show me the last example? Instead of placeholder, you just pop directly some value, right?
Right, this is the one.
Okay, so this will compile. Okay, okay, cool, thanks.
Yeah. Yeah, next we have higher order function. A higher order function is a function that has a value with a function type as an input parameter or a return value. Means you define a function, and to that function you can pass a function or you can return a function from that function. Such functions are called higher order functions. So if you see here, this is a higher order function. That's because if you remember, this is the definition of a function variable. This is the data type of a function variable. It means we can pass a function to this function. Whenever you see this type of data type, we already saw this type of a data type, that means it is a function variable, function identifier, and we can pass a function to this function. So let's have this. I think we will see in this. I think, yeah, this is much better for those things. So if you see, this is our function. This is a higher order function because it takes function as one of its parameter. In the body of this higher order functions, what we are doing, we are checking if s is not equal to null, then we are applying the function that is passed to this function. Then we are applying the function to the first parameter of the higher order function. Else we are just returning that function. If it is not null, apply the function passed as a parameter, otherwise just return a function. Now we are defining one more function here. This is a simple function. It is called reverser, a normal function just like any other function. It takes s as a string and returns s dot reverses the string here. This is a normal function. It takes a string and reverses a string. Means the data type of this reverser function is, it takes string as a input parameter, and the return type is also a string because we are just reversing the string in the body. So we can definitely pass this function to this higher order function, right? So we are calling this higher order function now. The first parameter is a string and second parameter is actually this function, because we have defined the higher order function as this, which whose second parameter could be a function. So we are passing a function here. So whenever we pass this, if you see, the result is null. This is the output of this function. What does the safe string operation higher order function say? If it is not equal to null, only then apply the reverser function. Otherwise, just return whatever is being passed to this function. We are passing null, so the return value is null. In the second call to that function, we are passing ready and the reverser function. So it is reversing that function and it is returning the value. So you got the idea, right? Why we needed this function variable and this function data type. This has been defined inside as a parameter to the other function, and hence that other function is called a higher order function, and we can always pass a function to a higher order function. Any doubts here? Any questions? Okay. Pardon? Yeah, reverse is a inbuilt function of a string. Yes is a string here. This reverse is a inbuilt function of the string. Somebody pinged, I think. Yeah, means it could be anything. So here we have one more function literals. Now, function literals are nothing but, we can if you see, earlier we had, this was a simple definition of the function. Then we have, instead of, okay, let me write here itself, this will be much better. We had def my double, which takes x as int and the value is x star 2. Then we had val my double of the type int, and we are assigning double to this. So what we can do is, we can always get rid of this intermediate step. This is the function literal actually. This is called function literal, the body. You can directly write this body here. Instead of having this name, we can directly write x star 2 here, but in that case we need to pass x as a input parameter. So what we are doing is, we are replacing this function with the body of the function, and we are getting rid of this. We don't need a intermediate definition of a my double. This is a function without a name to a function. There is no name, it's just the body literal. The literal has been given here. We need not, this intermediate step is not at all required. define a function, then assign that function name to this function variable. That is not required directly. Earlier it was in this fashion. Now we will directly replace the body here. This is nothing but function literals. So we can directly get rid of that intermediate function variable. We can directly place a body here itself. This is again a function variable which takes an x as an identifier integer, and its return type is integer. This is also a valid scenario where the literal is replaced with the actual function name. We don't need a intermediate function name at all. Yeah, this is what we are doing here. Again, we can we can call this doubler with actual value. You got the idea, right? We need not have this intermediate step. We need not have this intermediate step. We can directly replace this function with the body of the function. In that case, we need to pass the argument. Any questions there? If you see, earlier we had max was defined, max of a comma b. If a is greater than b, return a, else return b. Then we defined a function variable and assigned max to that. So now that is not required. This intermediate step is not at all required. We are directly putting the body of that function in our function variable. So in that case, we need to pass the actual arguments. So we are minimizing one step here instead of having these things. So again, the same in our case. Okay, as I said, we can do two upper. Because the reverse and reverser confuse us, as Sunil said, we can do it in this fashion. Yeah. Here also we are the same thing, whatever we did here, the same okay, same thing whatever we did here. We got rid of this intermediate function variable. The same thing we are doing it for the higher order functions. Instead of defining a different function, like instead of defining like convert to upper and passing string which does s dot to uppercase. and then passing this see, instead of doing this way, we define a function which convert to anything you pass as a string, it converts to a uppercase, and then pass this function to, this is what we were doing in our earlier example. We define a function, then pass this function to this higher order functions. But in the previous examples we saw that we can directly replace the body instead of passing the function, we can directly replace it with the body of the function. So instead of doing this way, we can directly pass the body of the function or pass the argument and the definition of the function directly to this function, to the higher order function. Since the data type is inferred, we can get rid of this data type. That's what I am doing in the second. I am writing the same function because data type is inferred by the compiler, so you need not specify the data type also. Earlier we specified string, but that string is not required, the data type is inferred. Also, again, it could be a shortcut. Already we have done a shortcut, again the shortcut is possible. Instead of we can say underscore dot to uppercase. That means whatever parameter is being passed, that will be taken as a placeholder. If there are two parameters, the first parameter, this is the definition of the body of the function. We can directly pass the body of the function as a parameter, and here underscore is the parameter of the higher order functions function. So if there are two parameters, the first underscore will be the first parameter, and the second parameter will be the second underscore will correspond to the second parameter. So I hope it's bit cryptic. Please do ask questions if you have any questions. Or did I lose you guys? Hello?
No problem, it's okay. You can continue. I mean, we are
Okay. So one more time I will explain it. This is our higher order function. The definition of this higher order function is, let me put the definition here itself. So this was our higher order function. Just ignore these errors because I am defining 2 times the higher order function. Just ignore this. Yeah, this is how we defined our higher order function that takes first parameter as a string and second parameter as a function. Now we are calling this higher order function here. We could call in this fashion also. We can call the higher order function as passing the first as a string and the second is this function. This is a function that takes input as a string and it returns uppercase, which means the return type is also a string. Since we have defined our higher order function which takes a function which has input as string and output return type is string, we can always pass this function as a function to this higher order function. So we also saw that instead of having a name, defining a function and then passing that function as a higher order function, we can directly put this body in place of the function variable. We can directly put this, but we saw that we have to pass the argument. This is how we are passing the argument. Again, we know that Scala will, this is a shortcut way of doing, passing the literal of the function. Then we saw that the data types is always inferred by the Scala compiler. So we can always get rid of the string data type because the Scala compiler infers for you. And again we are doing getting rid of the actual parameter. A parameter can be replaced with underscores. Underscore is a placeholder for the parameters. If there are two parameters, the first underscore will correspond to first parameter and the second underscore will be corresponding to the second parameter. We will have those examples again. If you see here, the same examples with two parameters we are defining. Here is a function, higher order function that takes two integers, parameter as the first two parameters and the third parameter is a function variable. And that function variable again takes two parameters, int parameters, and return type is again int. What we are doing, just doing f of x comma y, which means we are applying this function to the arguments, first two arguments of the higher order function. We are just applying that function. So how can we call this function? We can call this function in this way. Here the first parameter corresponds to this, first underscore corresponds to this parameter, second underscore corresponds to this parameter. So we are directly specifying the body of the function while calling the higher order function. So this will actually replace this. It will do x star y. Here x and y are 23 and 12. So the placeholder will be the always first parameter, the first underscore will be first parameter depending upon the number of parameters. The placeholder, depending upon the context, the underscore meaning of underscore differs. Earlier we saw that in pattern matching, underscore was like default case. It will match anything in the pattern matching. And also in doing import, if you see in Java, we do import some libraries dot star. It means it includes all the classes in that libraries. But in Scala, you can use a library dot underscore. It means it includes all the classes in that library. So depending upon the context, the value, the definition of underscore differs. In pattern matching, it was used to match anything, and in higher order function it is used to match the parameters that is being passed as to the functions of the higher order function. Similarly, we have a triple operation. Again, it takes three integer parameters and the last parameter is a function variable which takes three ints and the return data type is int, and it applies on the and the function applies on the passed parameters to the higher order function. Again we are defining the function here itself. So this is how a higher order function looks like. We pass a function to a function. Similarly, we can return a function from a function. When we return a function from a function, how it looks like, we can have def higher order function takes int, then f is a function that takes int and returns int, and we can have this function to return some function itself. In that case, the return type of this higher order function will be like in this way. This is a definition of a higher order function that takes one of the parameter as a function and it returns a function whose data type is it. That function takes int as a parameter and return value of that function is int. This is also a valid higher order function. Here we are returning a function from the function and also we are passing argument as a function. This is also a valid syntax. See, now we will see the use of this partially applied function. Whenever we specify underscore, it is called partially applied function and currying. So what we are doing here factor of is a function, simple function, and we are saying whether x is a factor of y, whether x divides y and there is a 0 remainder, like 2 is a factor of 4, we have 5 is a factor of 25, 5 divides 25, 10 is a factor of 100, means 10 divides 100. That's what we are checking with this function. So we can do in this way. As I said earlier, we call this function but we don't pass the actual argument. Instead we pass underscore. It will return a function variable, right? Once it returns a function variable, we can pass the actual arguments. This is partially ordered function. So if you see how we can make use of that partially applied function and reuse some of the function. So we have a function that is gives a factor of 3. So we can define in this way. We are passing factor of 3 and some function underscore. So it will return a function variable and we can call it as a multiple of 3. So this is like good to read. We are checking whether 78 is a multiple of 3. So this is how it could be used as a partially applied function by passing underscore. Instead of having in this fashion, like saying whether f is a whether 7 is a factor of 20, this doesn't look good, right? It doesn't give a readable format like what we are trying to do here. We can't say what we are trying to do here, but this will show you what we are trying to do. It is more readable. So we are not passing a variable here, instead we are keeping it as a function variable and then we are passing when we call this function variable. So this makes more readable. This is where partially applied functions are used. And also we'll see more other examples when we actually see Spark. In that case also partially applied functions are used. Partially applied means we are holding back some of the parameters. We are not giving all the parameters. That's the reason it will be partially applied. Any doubts here till now? Or did I lose some of you? If you have questions, please do ask the questions. Okay, silence. I assume everybody is following.
Yeah.
Okay. Yeah, here last time in all these example, the body of the function was just a simple expression. We are doing multiplication, arithmetics, reverse, single expression, the body of the function. But we can have a body of the, usually the body of the function will be much, there will be lot of expressions. So it is called a block, function block, literal block. So if you are having such type of function, we can use this open flower bracket and close flower bracket. Again, this is our same safe string operation, which is a higher order function, for which we are passing first parameter is a string and our second parameter is actually a function. We are defining the function here itself, and this is a much bigger function, not just a simple expression. So you can define in this way also. This is called literal block. The whole block of the function is written here itself. Yeah. Literals. Placeholder syntax. And then we have, this is one more for generic data typing. So this same example, triple operation.
Pramod, can you show me that block wala function example? 1 second.
1 second. Which one?
Yeah, the safe string operation.
Okay.
Oh, you are different.
This is the body of the function directly being passed. And this will be the last, this is the last statement of that function, which is again the return type is string. Here is what we discussed earlier, like generic data type. We have triple of A, triple of B. A comma B are the generic data type. It can hold any data type. So the first parameter is A of the type A. Second parameter is again of the type A. Third parameter is again of the type A. Then we have a function variable which takes 3 parameters of type A and its return type is B. So that's the reason the type parameter of this higher order function is A comma B. Means it takes 2 different data types. So to this we can pass any function, any definition. So if you see, we are saying it as int comma int. Only when we do star and plus operation, the return type of this will be int itself. So that's the reason a is also int and b is also int. But when we have division kind of operators, we will return a double. So that's like 2 divided by 3 will be a double, right? So that's the reason the first parameter is type parameter is int and second type parameter is double. Again, these things are not mandatory. It will be inferred based on what operation you are doing here. Similarly, what we are doing here is the definition sees, if you see the definition, we are doing second parameter plus the third parameter, and once we get the result of that, we are comparing whether the zeroth parameter is greater than first parameter. So based on the evaluation, it will return boolean. So the data type is int, type parameters are int and boolean. So the same triple operation has been used for different data types plus the higher order functions. So this is a triple operation, is a generic higher order function. It can work on different data types based on the what operation you are performing, what is your higher order functions, the function which is passed to the higher order function, the body of that function, what definition is the body of that function. This is what we saw, carrying multiple of 3, yeah, factor. So if you see again, one more example is there which gives a carrying example. So we have two parameters, factor of x, factor of group 2 parameter list x comma y, and we are checking whether x percentage y is equal to 0. That is nothing but we are checking whether if x is a factor of y, like 2 is a factor of 4, 5 is a factor of 10, 10 is a factor of 20, such kind of things. So we can define a function variable is even, and we can call factor of 2 and then pass an underscore. What it will return is a function variable. Is even is a function variable we can call later. So this becomes more readable now, right? Is even 32. Instead of giving, means we are reusing this factor of function to get a even number function. So that's what makes it carrying. It will be used for reusability and a better reading function. I hope you got, yeah.
How did this help the grouping the input parameters? This example actually carrying with grouping.
Carrying with grouping. Carrying is nothing but passing multiple parameter groups.
Correct. So how did this grouping help here? Like what is the impact of grouping just here? So instead of factor of 2 factor of 2 and space underscore, you would have given factor of 2 comma underscore.
Yeah, that is also good enough, but this is also one way of doing it. And we have some more examples on this, not just this. We need not specify this parameter at all. We can say this as an implicit parameter. We will see when we see implicit parameters.
Sure.
So in that case it will be much more clear. You don't have to pass anything at all. By implicitly the compiler will pass one of the parameters. We saw invoking higher order functions with function literal blocks. This is what we saw. We can specify the literal in the body itself. Sorry, as a definition, we can specify a function literal body to the higher order function. These two are the same example. So shall we go ahead with collections or shall we stop here? Hello?
Collection we can continue.
Everybody fine with collections?
Yeah.
Okay. Anu? Okay. No, I can't hear you. Okay. Yes. We can continue. So next we have common collections. Lists, sets, maps are the sequences usually we say are the common collections. Sequences, sets and maps different are categorized under different things. You can say sequences here. Sequences, sets and maps. List is a subset of sequence. So list is one of our collection, and most of the till now we saw how the higher order functions were called. So on collections, by default collections are immutable. That's what I said from the starting. Scala is immutable means the default collections are immutable. List is an immutable. So most of the higher order functions are methods of the collections. So we will see how those work actually. We will start using higher order functions on collections. This is normal list here. The data type is inferred automatically. We see it has inferred it as a list of integer. When we give list of red, green, blue, it says is a list of string. The compiler automatically inferred the data type for you. So these are the simple operations on list. Head will give you the first element in the collection list. The tail will give you the rest of the elements as a collection. So the way it is implemented, list is implemented internally is we have first element, then we have a pointer kind of to the second element. This is how it is implemented as a single linked list. One second. Yeah, this is how a list is implemented as a single linked list. So whenever we call colors.head, the first element is returned. Whenever we do the list.tail, rest of the elements will be returned as a collection, again as a list here. So this you can access the elements of the list using open bracket and close bracket. Usually we access the list with square brackets, but if you have paid some attention, the square brackets is always used for data types, to specify the data types. Here open bracket and close bracket is used to access the elements of the function. And in fact there is an apply method in the list. That function is called actually here. It is not a direct access as an index, but a apply method is called. So always an apply method can be ignored while calling that function. You need not specify the apply. This is actually colors dot apply one. This function is called, but you can always keep writing this function in Scala. This is not a syntax. This is not a like operator indexing. Actually, this is a function being called on colors object. Colors is a collection here. Yeah, we can loop on the collections. We saw that for comprehensions we need an iterator on the right hand side. So the iterator is nothing but our collection. So it will iterate and generate the variables and it will be stored here, and this is the result we are getting. We are just adding all the data in the list. This is simple for comprehension. Similarly, we have for comprehension and printing the data. For each is again a higher order function which is written on the collection. The data type of the function, higher order function means it has to take a function as a parameter or return as a function, but in this case we are taking function as a parameter, and that function takes any data type based on the collection and returns a unit. The for each always takes some data type as the input and returns unit as the return type. That is the for each syntax. If you see here, it is taking this higher order function is being called on the colors collection, and for each value of the collection we are printing the value. That's what we are doing. So map also, what is map? It also takes a, it is also a higher order function. Higher order function here in the sense it takes a function as a parameter, and that function takes some data as an argument, and it's like map is a transformer. It transforms. If you have seen, if you have learnt about set theory in mathematics, you will have set 1, then f of x, and then the next set. How do I say that? If we had a blackboard, that would have been good. 1 second. Okay. Then we had, right, this is one set and this is one more set. Then we had f of x, which takes each element of this collection and transforms into some other value in this collection. It takes, suppose there are some elements in this collection, it takes each element in this collection and transform into some other value in the collection. So that is what we defined in the set theory in mathematics, like f of x, based on what is the definition of f of x. Map is similar to that. It works on a collection and transform each element from the source collection into some other some other element in the other collection. Means it returns a collection. The only difference between for each and map is for each takes a, each works on each element of a collection and returns nothing. But a map works on each collection and returns a collection. And we transform each element of the source collection into some other element. What we are transforming here, we are taking c dot string, what is colors. For each element of the colors, we are providing the size of the color. So it returns a list. It takes a collection and returns a collection. That's what is map. And the difference between for each and map is it takes a collection, iterator in the sense, and returns nothing. It returns unit. Void means unit. The map is takes a collection and returns a collection, but transforms each element in one collection to some other element in the other collection. That's what we are transforming. For
So
each
this can be done using yield also, is it?
for comprehension.
Yeah.
Yeah, that's what I was saying. For comprehension is not a simple for loop in any other language. Internally, it is implemented using these maps and filters, higher order functions. That's the reason we can do it the same thing with the for comprehension and yield, because internally it is the same thing. Map filters are being used to implement the for comprehension. Yeah, similar as we have map, similar to that we have reduce. What reduce takes is a reduce is again a higher order function which has to take a function as the parameter. This is the function to the higher order function. What that function takes is it takes two arguments and returns. Here the definition is we are adding those arguments. So what reduce does is it takes a collection and returns a single element from that collection. It reduces all the elements of the collection into a single value, and that value is returned here. So what actually happens is the first argument is can be called as an accumulator, and the second argument can be called as a iterator. So the accumulator will be initialized with the first value of the list. Here numbers is the list. Accumulator will be initialized with the first value of the list, and B is a iterator on the list. So B will be starting from the second value of the list. So what it does is it adds first and the second value, and since A is the accumulator, the result will be accumulated in the first parameter, and this will go on till it does a plus here. First it will calculate 32 plus 95, and the result will be stored in A accumulator. Now B will iterate from 95 to 24. Now 24 and the previous accumulated value will be added. 24 plus the result of these two. So and it will go on till the whole elements in the list are done. So reduce takes in two parameters as arguments and returns a single element. Reduce, the name itself says that take something as a collection and reduce it to single element. That's what is all about reduce. Next we have set. Set is nothing but it is also a collection, but it has unique values, and also it is not ordered collection. Like list is a ordered collection. It means you can access it by a indexing. We saw we accessed it by like indexing colors of 0, colors of 2. It means list is an ordered collection, but set is not a ordered collection. You cannot access it by indexing. It has like contains is exist kind of function, but not an accessing by index. That's because it is an unordered collection, and also all the elements are distinct elements in the set. That's the property of a set. We can have all the same higher order functions, some of the higher order functions defined on set. So now most of the higher order functions are defined on the collections. First we saw functions, then we saw function variables, then we saw higher order functions to which function was passed as an argument. Then we are seeing higher order function defined on the collections. So this makes more functionality in Scala collection and less to code. Yeah, tell me. Yeah, no. Your voice is echoing. Probably you can type. I think we'll stop it here. I hope the session was useful.
Yeah, it is very good.
Okay. Yes. One second. Let me check on that before confirming. Fine. It is unordered set. We usually it's like anything. The set contains something. Function will be there to check whether a element exists or not. Let me check and confirm whether we can access in some way any other function method is available on this collection to access the contents of the set. Let me check and confirm on it. Let's not assume that we cannot access. Let me confirm that. Let me check and I will confirm. Fine. I think we'll stop it here. We'll continue tomorrow, same time.
Yeah, okay, Pramod, sure.
Yeah. Thank you, and I will be disconnecting the call. Thanks and good night.